welcome to this latest edition of Silicon Grapevine, brought to you by Synaptics. Today, we're going to talk a little bit about bringing edge AI to the industrial environment, and not just bringing edge AI, but scaling edge AI and some of the challenges around that. Um, for the discussion today, I have three guests we're going to be talking to. On the panel will be Nebu Phillips, who is a Senior Director for Strategy and Business Development at Synaptics for IoT and edge processors. We have Jamie Jeffs, who's Director of Industrial Automation at 42T. And we have David Steele, who's the Director of Innovation at Arcturus Networks. Hello, everybody.
Hi.
Hi, Nathan. Thanks for having us.
Hello.
I'm going to go into a little bit more about some of the sort of areas for edge AI. But before we do, I'd like to get some introductions. So why don't I start with Nebu? Nebu, tell us a little bit about you, your background, and what you've been working on.
Hello, Nitin. Thank you for the opportunity. I'm part of the processor division at Synaptics. We are focused on IoT compute solutions. I'm responsible for product marketing and ecosystem partnerships. We work with folks like Jamie in 42T and David in Arcturus to build solutions that bring AI native compute to different use cases. So as part of our silicon portfolio, we look to see how to remove a lot of the concerns around making IoT simple, easy, and accessible for developers across the spectrum. So there is an element of hardware design, scalable silicon approaches, and open source software that we bring together to the market so that innovation can happen at the higher levels, whether it be industrial or consumer or enterprise IoT market segment. So that's what I'm focused on.
Tell me, maybe just a little bit about your background. You've been at Synaptics a while, and you've been in this space for a long time as well.
That's right. So I've been close to 3 years at Synaptics. Prior to that, I've been at ARM for quite a few years, close to 6 years. Before that, stints at AMD and Broadcom, primarily in the embedded software space. But I've moved on to product marketing, product management, and business development over the last decade or so. So I've always been closely involved in compute domains, all the way from data center to networking and now into IoT. So as we see at the advent of AI, and especially if it's coming closer to consumer and end markets, it opens up a brand new set of challenges. There is a software element to it, there is a hardware element to it, there is an ecosystem partner element to it. So I'm quite excited in trying to bring these pieces together as a platform for IoT as part of the role at Synaptics.
And you've spoken at quite a few of our EE Times and embedded.com events on AI and general conferences. So yes, thank you. Next, I'm going to move to Jamie. Jamie, just give us a little bit about your background and what you're working on.
Thanks, Nitin, and thanks for asking me to join today. So my name is Jamie Jeffs, Director of Industrial Instrumentation. 42T is a innovation and design consultancy based in Cambridge in the UK. And as Nebu explained, we're working a lot with clients across different sectors, particularly in and around AI and how they can utilize it in their business. My background is actually industrial instrumentation. I've worked for sort of 20 years in different businesses developing products for various different applications across industry, and that's ranging from everything from heavy industry into large scale manufacturing, and that's both in sort of process control, environmental control, many different aspects, many different sensing techniques, types, etc. And so my role in 42 Technology really is largely in our product development and what we call our manufacturing innovation, where we're helping clients develop new and exciting new products, as well as supporting challenges or introducing new processes in things like manufacturing environments. So yeah, my background, as I say, sort of 20 years working in that, but increasingly now we're working with clients to answer that question about how can we start leveraging AI both in our products and in our processes.
All right. Well, thank you. Look forward to exploring that a little bit more. And David Steele, tell us a little bit about you. I know we've done a panel together in California, and I think you've got some good sort of background as well.
Yeah, that panel was a lot of fun. My name's David Steele from Arcturus. We're an Edge AI software company. I started sort of my career out doing embedded Linux, so that probably dates me a little, a little bit as to where I started. But then at Arcturus, what I started doing was working on voice and video communications. And really, once you have video, you really want to do something with it. And in 2017, I started being responsible for an Edge AI group that was really looking into the application of vision AI in industrial, which is Arcturus's key focus. So what we do today for our bread and butter is vision pipelines and tools, and we focus primarily on industrial applications. For us, industry isn't just the physical plant industry, though, as well. We think of industrial solutions also in sectors like transportation, for example, with public transit, and so we have a pretty broad portfolio of what we do and a pretty diverse number of solutions that we work on. But I think where it's really interesting is really in kind of where Jamie is focusing on, which is in really transforming production, factory floor, those sorts of applications, and that's what we're really focused on today.
Well, I'm fascinated, and I'm just going to bring a little bit of a little anecdote here. In the late 80s, 90s, I used to work with a company that was making automatic optical inspection systems. You can see how far vision AI has gone. Vision inspection systems. I mean, you're now using AI. Then it was just using a camera and sort of looking at it through these big automatic test equipment systems. But it's fascinating. Well, good. And that really brings me to the first question, which is the first sort of discussion point. Why do we need edge AI in industrial? And I can see it in things like wearables and the big trend in 2026 is physical AI and robotics. But I guess there's a lot more to it. Maybe I don't know. David, you want to start?
Yeah, sure. I mean, you talk about classic vision inspection sort of solutions, and I mean, rigid algorithms, rigid heuristics, not adaptable. This is the limitation of that, and which has driven sort of the AI adoption in industry. That's really what's transformed what we've had as sort of a legacy solution into what we're using today. And I would say that vision AI is part of it, and then there's also the extension of that. Now that we're seeing the application of large language models as well, looking through data that's being used on a factory floor, doing this sort of at the edge. And when we mean edge, we mean without cloud connectivity, without the data sovereignty issues, that could be tangled up with geopolitical issues that no one wants to touch right now.
Right.
We talk about connectivity, we talk about private data, all of those things. So those are all reasons why I would want to do this at the edge and using AI.
And Jamie, I mean, some thoughts from what you've been doing. There's obviously a clear sort of trend towards going to edge AI.
Absolutely, and I'll pick up on a point that David made there, which is about sort of data sovereignty. Sovereignty. So thank you. The manufacturing industries we work with and the clients that we work with absolutely have concerns over cloud compute capabilities, and we work with a lot of large-scale corporate organizations that are concerned about the risks that their data leaving site and or exposing their systems to attack. So we've seen it a lot, certainly in the UK alone this year, or last year I should say, where that's caused major issues. So there's a natural leaning towards processing their data and therefore native AI solutions on the edge. So edge processing from that perspective. Beyond that, though, I think there's a big drive towards some of the benefits that it can potentially provide in terms of, again, thinking from a manufacturer's perspective, an end user's perspective, in terms of the reduced latency that you'll be able to achieve from that, sort of actually achieving some real-time analysis. Some of the processes we're talking about are, milliseconds processing requirements to be able to capture some of the insights that the AI has the capability to do. I'd also flip that and look at people that are looking to embed AI into their products. I think historically people have looked at cloud-based solutions and software-based solutions that they can supply to their customers. But if you're an instrumentation manufacturer and you're looking to leverage the capabilities that AI can provide, being able to embed that directly into your products, adding value into the data that those sensors in some cases are providing right at the source is an actual commercial opportunity that
Yes.
perhaps having standalone solutions doesn't provide them. So being able to have something that can be an individual sensor by sensor processing capability, much of the work that David's doing with the work he's doing with vision systems, but it can be applied to all types of instrumentation, as Nebby mentioned before, whether that's time series data, whether that's audio, whether that's visual data. So I think there's a real commercial opportunity for companies, whether that's instruments, machines, embedding that value into their products. And that's all part of the verticals that we're working in, right across manufacturers at the top end, right through to OEMs and sensor manufacturers feeding those industries. So huge amounts of potential. The edge, as we say, edge versus cloud, we know hybrid opportunities exist for those as well. But edge versus cloud for companies looking to leverage their data and leverage AI, I think, is an exciting opportunity that we're working with our clients on increasingly.
And maybe I think in terms of the edge, I think that's where you've been working quite a lot. So why do you see customers saying, okay, well, we want to do edge AI?
Yeah, so to both David and Jamie's point, right, Nitin? So we see the story around the benefits of edge compute in and of itself is not that new, right? So concerns about latency, privacy, all of it, it's just been associated with the move towards, in general, edge compute. What we see AI doing as part of this transformation is to drive like another level of operational efficiencies. So, and all these modalities, the way you interact with your environments are beginning to change. People are becoming a lot more comfortable embedding vision-based functions into devices. So we too see vision as the leading modality among vision versus audio versus voice versus time series. And even traditional computer vision functions, right? Even before large language models, all of these, there is more acceptance to embed vision-based functions into devices. And as you know, semiconductor life cycles go anywhere between 5, 10, 15 years. And we see a lot of different stages our customers are currently in. Where some of them, they know exactly how vision can drive further efficiencies into their product designs, to others who are still experimenting with use cases, but they don't want to release products into the market for the next 5 to 10 years without any kind of AI acceleration capabilities built in. So we see an entire spectrum of people who are sort of working with this design challenge. And yeah, vision is something that there is more, whether it is smart camera systems, inspection systems. So as we see that, the language around how to stand behind the AI technology stack that integrates vision is where a lot of the deployment considerations are beginning to happen. So that is something that we are actively working with our partners, experts like David and team and Jamie and team, to understand how we can provide the most scalable platform to build these solutions. So it's end of the day, it's about driving operational efficiencies, and it's not like incremental. We see it's like a massive changes in overall total cost of ownership, for instance. So we are in that stage where we are benchmarking systems at that level, trying to speak an OEM language on the benefits that vision embedded systems can bring to the factory floor. So that's the stage where we are, and we are excited to work with our partners to benchmark and call out the value that these systems can bring.
I mean, just to summarize, also as an editor, we're speaking to the whole ecosystem on a daily basis about this, and the three things obviously come to mind are sort of the latency. You need fast, fast response. You need privacy. You talked about the data sovereignty and security. I think you also talked about making sure it's not hacked or the data doesn't get into the wrong hands. So I think those are the key sort of things we see as people telling us. But I think that sort of brings in whatever all of you are saying here. But in terms of actually implementation, we talk about sensors and embedding sensors into. Is it just purely a case of putting sensors into processing into the sensors, or do you have systems? I mean, what kind of range of systems are you seeing implemented? David, maybe we can start with you, or Nebu. No, sorry, let's start with Nebu.
So we do see a range of solutions, Nitin. So there are companies that are interested in bringing in more intelligence at the sensor level. So we definitely see decentralized kind of a move into where processing is happening, and still very much an evolving space, because the software and the platform, the design challenges at each of these aggregation points, it's all very fragmented still. But we do see there isn't like one golden architecture, all processing at the
Boom.
sensor level versus everything at your edge server within your factory. That is the entire range, right? For edge compute. So we see a range of solutions. And from a silicon provider standpoint, this is what goes into our thinking about how do we scale the compute capabilities, and keeping in mind the cost and the power, also to enable these different tiers of AI accelerated compute. So for us, right, that goes to not having rigid architectures when it comes to AI capabilities, and also scalable and open software that we can make as a platform for our design partners. So yeah, no one set answer for this, whether it is embedded at the sensor level, or at a gateway level, or a hub level, or dedicated systems. Yeah, that's a design space that we see today.
David, what's your thought?
It's an interesting question. So there's a big diaspora of silicon that's available. At the and we're kind of, in a way, at Edge AI, we're sort of almost on a second generation of that silicon. The first generation of that silicon was pretty complex, powerful core complexes, lots of NPU acceleration. And now we're looking at lower power solutions coming in on the low end as well, which are more sensor-based solutions, where we're not interested in encoding and streaming video necessarily that a human's going to review, that's annotated with AI. What we're more interested in getting is just the metadata from the edge. And those low power components are coming in at a price point that makes it very compelling to do some basic analytics at the edge. I mean, we're talking about doing things like perhaps like package inspection. I mean, on the transportation side, we're talking about things like LPR, license plate recognition, or counting, or those sorts of things, which can really suitably be done on these very low power next generation processors, where we can use the current generation of processors for doing the more sophisticated pipelines, where we may have one or more model, an output of one model, maybe an input to another model, which is how we develop pipelines, or there may be more than one model running concurrently, where we need that horsepower to process those applications. So where we might be doing anomaly detection, inspection, counting, all of that in one process control node. So I'm not sure if that was a roundabout way of answering your question.
No, it's fine.
But
I think I like the word diaspora. I mean, it is it's quite interesting. Jamie, some thoughts on sort of like that whole sort of ecosystem of systems, whether it's sensor, whether it's SoC, whether it's but I guess Nebu also said it could go into different areas. So, what's your thoughts?
Yeah, I think I like the term system, certainly in terms of the way that we think about the deployment. So obviously we often start with our clients trying to help solve a problem or make an improvement before we define the solution. But doing that then is about understanding the capabilities and the right fit for the hardware in the processing sense of what do we need to select. And David talked about the range available. What's appealed to us in terms of working with the Synaptics Astra device in our recent work is that balance between performance and scalable deployment. Because as David pointed to earlier, a lot of the challenge is putting multiple, what you might say, multimodal sensing capabilities across a range of areas to really get insights from things that you might not otherwise capture through traditional one-to-one sensor networks. And obviously, in industrial space, you've got large PLC providers really adding the sort of connectivity, if you like, on site, and a lot of the big players have produced their own edge-based solutions that sit within the PLC controls for automation. But really beyond perhaps some of the more traditional applications that you spoke about, obviously being able to leverage some of the capabilities that can now be performed at the edge with the sort of scale size models that can now be deployed for sensing, that is really exciting, because ultimately you're being able to demonstrate the value. What is the return? Because that's a big question. All our clients are asking us, how do we use AI? How do we leverage it? But in a business case sense, not in a pure technology sense. And from as Nebi talked about, the efficiencies that's going to bring them, both in terms of their design, but also the implementation. So for us, from a sensing perspective, it opens up many, many opportunities, but it's about selecting the right solution to help solve the problem and demonstrating that in a evidential way that can back the business case to go and invest in this, because obviously at the scales that a lot of our clients are looking to achieve, beyond just sort of prototyping and use case. So yeah, really keen to see obviously some of the evolutions. I think one of the major things that we're seeing in terms of capability at the edge is this natural language capability, because I think from a lot of users' perspective, there's a generational thing in industrial, which is, they expect to be able to sort of leverage the kind of technology they have in their home and in their normal life, and some of the abilities to be able to interact with devices in the same way as you would in an industrial plant, as you would in your home, is a driver for a lot of users as well. So balancing that kind of drive for technology, but also that drive for a solid business case to invest.
Well, it's interesting because you talked about the consumer expectations driving what it's happened with from iPhone to the automotive environment, where they expect that interaction, and now what you're saying is that kind of expectation is coming in this industrial environment as well. But interesting thing you said was it's not a case of a technology; it's a business. So is a technology pretty implementation pretty easy, and it's more about the business case? I'm guessing it's not, but I think you kind of implied that.
Yeah, from my perspective, obviously, I talk to a lot of our clients at a sort of commercial level, but obviously,
Yeah,
it's the teams here and in David's teams and Neba's technical teams there that have to go and do the hard yards. No, it's
yeah,
not easy, but
yeah.
I think there's very much a drive towards being able to do it in a faster, more scalable way, and I think things that enable that are some of the things that Nebby touched on, which is about making sort of the access to be able to build and prototype and move through the development phases quickly through open tool change, through open access to platforms to build on. Those are the things that make what would historically perhaps be more challenging much easier for companies like ourselves, but also our clients, in being able to more rapidly assess, can we actually deploy this? Is this viable? Is this something that we can both do technically as well as commercially for our business?
Yes. One of the things I think in terms of implementation, and I think maybe I'll ask you, David, is when we talk about AI, we think about large language models and the data centers, but really for edge AI, we're talking really tiny models. I mean, what really for the most simplest, what are we looking at in terms of model size, code size? I don't know whether you wanted to answer that or neighbor wants to answer that.
What I was going to say is, well, really, it's kind of maybe not the right question to ask.
Okay.
The way I would frame it is to think about the knobs we have at the edge.
Hmm.
So sometimes it's basically the two factors we look at for edge processing for AI are performance and accuracy. Those are the two big things we're always concerned about, and they're a trade-off in most cases. So when we start looking at using larger, more powerful models at the edge on specialized compute, we have to look at more optimization. We might need to look at slower frame rate, but we're going to get more data, more specific data to our use case out of it. Whereas when we're looking at something, Jamie mentioned high-speed processing before, then we're going to be looking at a much lighter weight model, lower input size into that model. Then there's a number of things that we can do that can improve our overall pipeline performance. For example, what we often see at the edge is that the pre-processing functions for a model, which are generally done on CPU, can take as much or even longer than the forward pass of the model itself when it's done on specialized compute such as an NPU. We can actually take some of those functions and optimize them, either to look for special activity triggers that will handle that pre-processing function smarter, or we can look at adding some of those pre-processing functions into the model itself and run it on the specialized compute. So the point that I'm trying to make here is we've got a bunch of knobs and those knobs we can tweak to extract exactly what we need, the value we need to get for the customer out of it. So it's definitely not a one size fits all sort of solution.
Well, I guess that, but I wanted to start somewhere, and I think that's the way to start it, the
Sure.
discussion. I mean, I'm not sure if Jamie has sort of perspectives on that as well.
Yeah, and I think there's a point there about capability within the companies that want to implement this. You have companies like David's team at Arcturus that have the sort of data science capability to be able to train and optimize models. And obviously, with more open source available tools and some of the capabilities of even, as you say, these small models. But it's about building tools that enable people to leverage these kind of functions without having that level of capability of a data scientist. And I know David's doing some really exciting things about things like no-code machine learning, where you can use the tools that they've developed based on the platforms from Synaptics and the Astra device that do make these kind of things accessible and easier for people to use, rather than having a team of quite frankly, hard to obtain data scientists. There's a lot of companies out there wanting to recruit into that space. And I think if you're a data scientist in Cambridge, for example, you're in high demand. So having those kind of bridging that gap between sort of pure technology development and software engineering to people being able to utilize those tools themselves.
Let's switch gears. Let's talk about some real world applications. Some examples of things you've worked on over the last few months. I don't know if I get Nebu last, but let's start with David, because you've been working on quite a lot, and we talked about some of those when we met at Synaptics Tech Day in 2025. So tell me a little bit about some of the things you're seeing.
Yeah, and one of them, I think I may have brought this up actually at Tech Day, but one of the more interesting ones is we've been working with sawmills. So sawmills have a number of really interesting use cases, and this is why I like using this example. So a lot of them get their ingestion of logs from these storage ponds, and these storage ponds look very different in the middle of winter, especially in the northern regions, than they do in the middle of summer. And so in AI, we call this drift. So drift is when there's a difference between what the data the model is seeing in the real world versus the data the model was trained on. And so here we have a case of trying to implement an AI solution that's going to progressively get worse as seasonal variation affects it. And so classically, we would need to get data for that entire data set over a period of 1 year before we could roll out a production grade model. And here's an example of where the tooling that Jamie was alluding to really, really helps us a lot, because it allows us to continuously gather the data, continuously train models, this whole sort of ML ops virtuous lifecycle. So I like using that example because, it really helps emphasize where drift can actually take place in a real world sort of case. Beyond just a concept drift where a company may want to change a SKU, a part number, a color, or something like that.
Yeah.
But and kind of speaks to kind of accelerating this sort of go-to-market strategy that we can assist with too.
Okay, Jamie, some examples.
Yeah, some examples. So we've been working with David and his team and Nebu and the team there at developing on the Astra platform over the last sort of 18 months or so. One of the sort of most specific use cases we were developing around was something called line clearance in pharmaceutical manufacture. So this is a very often a separate process where between each batch of production, it's manually inspected to make sure there's nothing left over in the process. And obviously anything that could be a contaminant left over in the process after a batch run is a particular risk in that industry. It's a heavily regulated industry, aspect of the process, I should say, in that industry. But we were developing on the basis that you could process many, many different vision inspection points across the process in an automated way, in a parallel way to be able to both increase the speed at which those checks can be made, because obviously any delay in getting a production run started is a big impact in those sort of high volume, low value production processes, but also being able to automate that process such that you can have better accuracy of those checks, not be so prone to perhaps human error. And we've been having lots of different discussions with potential clients for that solution since demonstrating that at Embedded World last year. But that really leans into many different automated visual inspection, where the things we touched about on earlier about why edge is beneficial can really be demonstrated in that way.
All right. Nebu, so tell me a little bit about some of the challenges you're seeing with Edge AI implementation and things you're seeing with your customers.
Yeah, so basically, if you look at the Edge AI technology stack, there are different aspects all the way from compilers to models to frameworks to tool chains to data sets. So the challenge is try to see what would be the right sort of pipeline that we can enable for the ecosystem as a whole. And it means there's more partnerships required, less proprietary or black box kind of solutions that we want to bring to bear. And we feel this is a space that is still very much in its early stages. So we want to have very meaningful partnerships that can create sort of recipes for how to do Edge AI application development for IoT. So we don't want AI to be like increasing the fragmentation so much that it becomes again, walled garden experiences for end users. So that's what we are focused on. So simply put, it's all about the fragmentation. We are working to see how best to address it and to make it a bit more user and developer friendly. That's been our focus.
David, what are the challenges you're seeing?
Well, I think on a whole, and especially when we talk about vision and AI, I think getting that initial data set curated, getting the proper level of data set analytics and model training to get a really truly production grade model is always an issue. I think that the more specialized the data the client has and the more specialized the implementation, typically the more of a challenge it is to actually get that first level of data. We're talking about production systems that may not actually have cameras on them yet. So we may not actually even have necessarily the right type of data for us to be able to start working on. So acquisition, always an issue. I always think that's a bit of a challenge to get a project started, and that's always the initial kickoff that any industrial customer needs. So they need to think about that when working towards a project like this. And then there's some industry challenges. Maybe a bit of the elephant in the room that we haven't talked about is DDR availability.
Okay.
So, those sorts of things can be a pretty big challenge too. But definitely on the tools side, we're working with that. The industry is always going to have its ups and downs.
And I think you also
challenges.
talked about scalability, which is one of the challenges as well. Not
true.
just
One of
the processes, but the actual models themselves.
Yeah, true. One of the first questions we always get asked when we first meet an industrial customer is, this is great. You have this demo set up using one camera and one edge device, but my production line has 30 cameras on it and I've got 15 production lines. That's a very different type of problem. So how do you get from here to there? And really that's what we're trying to address with our fleet management tooling, which will provide sort of the three key things. Basically, the ability to manage a fleet of devices, including configuration and firmware management, the ability to get all of the live data that's being produced and provided in a usable and meaningful format in a dashboard. And then the third thing, which is model adaptability. So giving the industrial guys the ability to control their own destiny by being able to adapt the model without having to call California and say, hey, get me a team of data scientists to help me with this, to provide the tooling that provides that click-through workflow to facilitate that.
Or Cambridge, UK, which takes us to
Yeah,
Jamie.
or Cambridge.
Jamie, some of the challenges you're seeing.
I'm going to take a slightly different stance on this and
Yeah.
just start with actually awareness.
Okay.
I think for us that are sort of fortunate enough to be working in this space, we're kind of aware of some of the latest technologies and advancements, but actually even the term edge is not that well understood in industrial process, considering a lot of the operators that have their day-to-day challenges. So I think it talks to what David was saying in terms of data capture, but I think it's also about awareness of what's capable and what's possible. What is the art of the possible now? Because things are moving at such a pace. I think once you get over that hurdle, I think capturing the data, yes, absolutely is going to be critical. And we always talk to our clients about where are you starting from? What's your baseline in terms of your baseline truth about your data? But I think it's also then about integration into these existing infrastructures. I think a lot of industrial plant operators are not going to want to have to buy full new sets of equipment to introduce AI. They want to be able to have that retrofittable capability into their processes. And then beyond that, then it's also the fact that they're going to be used in harsh environments. And we're increasingly seeing systems and devices that can be deployed at the edge close to source, which are rated to the right type of IP ratings and the sorts of things that matter to operators in terms of, regulatory requirements around explosive zones. We do a lot of work in ATEX environments. It's incredibly challenging. So having the kind of industrialized, ruggedized capabilities to be able to deploy very close to the source. So these are all areas that we see as the practical challenges, if you like, of actually getting to a point where you can put it into a site, maybe outside of the sort of relatively easy application in a lab or on a benchtop demonstrator. So yeah, the real ruggedization, implementation, ability to be able to retrofit, and also having that capability to understand the capabilities of technology as it is today.
So I'm going to close now a little bit. I normally ask about lessons learned, but I think you talked about some of those in terms of the challenges. So what I might actually ask is, what's to each of you, what's your advice to, based on your personal experiences, on your company's experiences, what's your advice to people out there about this topic, about getting intelligence into the industrial environment, I guess, which is really what we're talking about here. Maybe I will start with Nebu, and then we'll sort of go around. Nebu, what's your advice to customers, base or the industry, not just customers?
Yeah, so from our standpoint, again, for this, I will refer to what Jamie mentioned. It's all about awareness. And we have to demand more open approaches to solutions. Otherwise, very quickly, you will realize that you will be locked into a stack that becomes quite rigid quite quickly. And then it is all about understanding the actual product requirements and trying to map it to the capabilities of the AI tech stack. So, for instance, we use the word TOPS a lot to describe NPU capabilities, right? Is that the right sort of metric to go into approaching a problem? Is TOPS the perfect rating? Is it more about how best your AI engine can be utilized? What is the effective utilization rate rather than raw TOPS? So things like that, right? That comes with awareness to ask these few levels of questions that are a bit deeper, that will make people choose the right kind of solutions. So we feel the market is moving anyway in that direction. But then, yeah, openness and a deeper understanding about the nature of the AI block that you really need in your application is something that we have worked very closely with the partner ecosystem to create more messaging around.
Okay. Jamie, advice to people based on your personal experiences and your company's
Yeah,
experiences, I guess.
of course, thank you. Yeah, our experience is really that you need to start from that position of understand what problem or what improvement are you trying to make. Have a very clear goal with the task that you're trying to achieve with AI, particularly with Edge AI, where you're trying to do it often at a very local level. So understand that, because that's got to underpin everything that you do. I think there's been some statistics, I think it might be Forbes or MIT, talking about the number of sort of generative AI projects that have failed. And I think a lot of our view on that is that understanding what it is you're setting out to achieve achieve, and then being able to build a solid platform under which to then go through the process of developing that is a fundamental. Because I think you touched on it earlier, Nitin, in terms of this sense of, is it easy? Can people just get the latest bit of hardware and software and start playing with things? And you absolutely can. But in an industrial context where you have all these different challenges, both environmental as well as technical, as well as some of the really challenging applications they're going to be working in, having that solid foundation of what is it we're looking to achieve, and then thinking about, well, what data we have to support that to start with. If we don't have that data, how do we get that data such that we can actually process it in the right way? And then perhaps iteratively being able to develop and prove out that the insight and the output that you're getting from your system is actually telling you something of insight that you can build on. So I think our advice really is to take that. Perhaps it's a more traditional approach to sort of research and development, but one that we think is very applicable in industrial areas where, being able to demonstrate that potential return on investment is going to be really important. So, yeah, that's one of the key things, I think, given that a lot of people are starting from very different places, and you need to be able to stand where you're starting from and where you want to get to.
Thank you. And David, your advice to industry?
Yeah, I think that there's what we run across fairly often is just there's a lot of really great starting places that especially whether it's a pre-trained model from Hugging Face or whatever it may be, and this can be great to kickstart projects, and it's great to do that sort of POC that can get the guys that control the purse string sort of excited about how things apply. But what often happens with clients that go that route and that are a little bit naive to the whole sort of process behind building production grade models is they can kind of get caught in a little bit of a gap. And that gap is either what they're evaluating can't really be extended, or they don't have the capabilities to extend what they need to deliver from a production level. So this leads to problems in projects, and that's something we want to avoid. So understand that what is out there is great from an evaluation standpoint. It's great to get that POC bootstrapped, but you're going to have to train a model at some point. So, you need to have that capability, and you need to not be naive to that's required to achieve production grade level products.
Well, thank you, gentlemen, everybody, and Jamie Jeffs, David Steele, and Nebu Phillips. Thank you for this special edition of Silicon Grapevine, brought to you by Synaptics, and we'll look forward to speaking on the next one.